Okay, guys, let's wrap up chapter 1 part of the review. First 14 questions. Number 11 is next. Okay, this one says use transformations to graph the function, state domain, and range. Oh, this is an easy one. So we have basically an absolute value function, but we've got it doubled. We've got it. There's a subtraction by 1 inside the absolute value and an addition of 3. So real quick, let me just talk you through what's happening here. What are the transformations that are occurring? First of all, this -1 is happening before the absolute value is taken, right? So that's a shift to the right by 1. Here I have a +3, that's a shift up by 3. And then this 2 is just a doubling, that's making it a vertical stretching, right? Vertical stretching. So I got a vertical stretching, I got a shift by 1 to the right, and a shift up by 3. Okay, so this is one of those cases where the base graph looks like this, where it has point right at the origin, right? So what I like to do in this case is just start by shifting that center point. And what is a shift? Again, just repeating myself, 1 to the right, 3 up. So 1 to the right, 1, 2, 3 up. So that start of the V should be now there. Notice this is a positive number, so I don't have to worry about reflecting downwards. It's going to still open the same way. And it's going to open twice as fast upwards. So instead of normally you go up 1, right, or left 1, up 1, right 1, up 1. Well, because this is a 2, I'm going to go left 1, up 2, and right 1, up 2. And then just connect those dots. Okay, not making that a straight line. Thank you. And then this side, same thing. Make it straight. Thank you. Just like that. Yeah. Okay. So that's it. So we use transformations to graph it. Now state the domain and range. And it's pretty obvious, right? Domain is everything. And then the range is everything. Oops. I always forget to write hard bracket there. Hard bracket because this point is included, starting from 3 and going on upwards forever. Okay, so that was 11 we just did. That was 11. 11 done. I wrote 11 just so that I can erase it again. Okay, 12. Given f of x equals the square root of x squared minus x plus 2, find two functions g and h such that f is equal to h of g. Note there are many possible solutions. So many possible solutions, yes, but one very obvious one, and that is to let the outer function just be the square root, right? Outer function is the h function, that happens second. The one that's furthest to the right happens first, right? This is h of g. So I'm going to start with the g of x. G of x, let's make that x squared minus x plus 2. And then h of x, we'll make that just the square root of x. Okay, so that h of g of x would be the square root. H takes the square root of whatever g of x was. G of x was x squared minus x plus 2, and that's exactly what you wanted. So the answer is this portion here. This part was just a check. You don't have to write that down. Yeah, pretty light work, right? Light work. That was 12. You're not the only option, but the most obvious and the easiest option, I think. You could have just done one of the functions, maybe say like only does x squared, for instance, or something like that. But that would be more complicated. Okay, do you guys want you don't want to see that. You don't want to see that, right? Okay, 13. Sketch the graph of this thing. I've got a piecewise function, x plus 2 where it's bigger than 0 or equal, and x squared if it's less than 0. Okay, simple basic functions, and I'm just breaking up into two chunks where I'm less than 0 and when I'm greater than or equal to 0. So let's start with, we'll go top to bottom. It's kind of written a little weird, to be honest with you. It says when x is greater than or equal to 0 first. Usually you would start from left to right, but you don't have to. There's no rule that says you have to, I guess. So when x is bigger than or equal to 0, it's just x plus 2. X plus 2 is just this straight line graph, right? Except shifted up by 2. So let's graph the whole thing first. It's got a y-intercept of 2, right? And then you'd go up 1, right 1, like this, right? Something like that, right? You go right one, up one, to land right on top of it. Except it says this should only apply when x is bigger than or equal to 0. So I don't want it to be on the left. Only when it's from that point onwards. And since it's greater than or equal to 0, there should be a filled in circle there. Now, to the left of 0 should be x squared. X squared looks like this parabola, right? But that only applies when it's left of 0, so not including that spot. And then to the left like this. Okay? So that's the sketch. And if you want -1 squared is 1, so you get that point. -1, 1. -2 squared is 4, so -2, comma 4, like that. Okay, that's 13. I forgot to label again. So that was 13 just now, folks. Now time to erase it. Okay, last one. Oh, shucks. I should have kept going, yeah, because then I could have actually probably kept this with the previous video since these are going pretty fast. Let f of x equals x cubed, let g of x equals cube root of x. Find f and g of f. Determine if they're inverse functions. For these guys, make sure you also pay attention to the domains. The domains and ranges, they should be swapped if this is going to be true. But in this case, there's no worries because x cubed domain is everything, range is also everything. Cube root of x domain is everything, range also everything, right? So that's looking good, promising. Now let's find f of g of x, and g of f of x. Starting with f of g of x. What is that? That's f of, what is g of x? The cubed root of x, right? Now what does f do to that? It cubes it. So I've got the cube root of x, but cubed, which is, of course, just x. So that's good. Okay, that's looking good. What about the other way around? Let's see if we can just squeeze them right here next to it. G of f of x. Okay, what was f of x? F of x is x cubed. And what does g do to a function or an input? It takes the cube root. So this would be the cube root of x cubed, which of course is just x. So anytime you take a composition and you end up with just x on both sides, as long as your domains and ranges are also swapped, then that means they are inverses. So these are indeed inverse functions. So there you go. And that's it. Review of chapter 1 finished. You can expect any questions from chapter 1 to be a subset of these types of questions that we've covered from 1 to 14. But I'm not going to include every type that I reviewed here.